Project is the Deforestation Response Robots. I'm Valora Brizette.
And I'm Dylan Roleri.
I'm Petra Stewart.
Kiara McCrae.
So, introducing the Deforestation Response Robots. The issue these will be addressing is the deforestation in the Amazon rainforest due to things such as illegal logging, mining, and just unsustainable land use. Our projected customers are the World Wildlife Fund and the Brazilian government with the Amazon Fund. The current practices that are in place right now are monitoring and mitigating deforestation using drones to navigate and map the rainforest, which is then reported back to officials if there's any illegal activity. Overall, this isn't doing much to mitigate the problem. So ours differs by having 4 different types of robots in the system that communicate with each other. And there's on-site monitoring, testing of soil and trees, detection for illegal logging, and reforestation efforts. The first robot is the trash tracker. The primary responsibility is to move through the rainforest on the continuous track, detecting trash, fallen trees, and debris with the ultrasonic distance sensor and the IR sensor at the bottom. When detected, the motor will stop and the servo activates the claws of the robot to pick up trash. And if a fallen tree is detected, it's then communicated with on-site teams to coordinate clearing.
And then going with the trash tracker is the Terra Guard, also on the ground. The difference is it has a probe and a retractable claw that's constantly picking up samples from the rainforest floor and reporting that back to sort of central monitoring station. It does also communicate with the other robots through cameras and sensors.
Scoutbot, our autonomous aerial drone, patrols the rainforest canopy using HD and thermal cameras, GPS, and a directional mic to detect fires or illegal logging. Powered by solar panels with a backup battery, Scoutbot flies on its own and instantly sends tagged coordinates and live footage to the ground team.
The canopy crawler climbs up the trees of the rainforest using clawed wheels with microneedles. They're powered by DC motors and controlled remotely or autonomously. Cameras at the top and the bottom of the robot capture images while a probe controlled by servos collects bark samples. The robot is placed at the tree base to begin the operation, and its main purpose is to assess tree health through visual and physical data collection.
And one of the strengths, really, of sort of this collaboration of robots is that they can all work together. You have the Scout bot that's overseeing the rainforest, detecting that illegal logging, detecting if there's anything that looks off and is, not doing what it's supposed to within the rainforest. Then on, sort of the canopy crawler is on the trees, taking sort of health, samples, seeing how that is. Meanwhile, on the ground, you have the trash tracker that is collecting samples, but also cleaning up waste and things that may be harmful to the rainforest. While you have the Terra Guard that's really taking those soil samples, it's going through all the different nooks and crevices of the rainforest to make sure things are healthy. To get an idea of how they all work together, ultimately you got your Scout bot, overlooking, making sure things are looking good, your trash tracker and your Terra Guard on the ground as they're moving along the rainforest floor, and then the canopy crawler is going up the trees. They are communicating in real time, but there are certain samples like the Terra Guard and the canopy crawler that do come back to base camp and are analyzed further.
We benchmark systems like Auto, Wilderness International, and Planet Pulse, all great but limited. They either lack soil level data, real-time patrol, or robotic response. What makes our system different is how our robots work together to collect ground and aerial data, remove waste, and replant, all while running on solar power. It's proactive, precise, and built for sustainability.
Our robot system combats the deforestation of the Amazon rainforest using integrated aerial and ground robotics for monitoring, response, and restoration. It improves on existing solutions by combining detection and action into one platform. All the robots are working together. The project emphasizes the importance of clear roles, collaboration, and flexible design. With more time, we would have enhanced the detection using machine learning and probably created more compact and deployable models.